A simple example of trustless collaboration enabled by Cairo is to delegate the execution of a Cairo program to a third party that you don't trust, but still being able to use the result of their computation thanks to the presence of a validity proof. This is a very high-level overview of a system that doesn't require trust, but how does it actually work? Let's take a look at the internal modules and their roles. On one hand, there's your device, a regular computer that could be a desktop, a laptop, or even a smartphone. On the other hand, there's the device of the third party, a computer with much greater capabilities that will be in charge of executing your Cairo programs. It all starts on your device and with your program written in Cairo. Once the program is ready to be executed, the first step is for you to compile the program into Sierra, an intermediate language. The Sierra code of your program is what you would send to a third party, not the original Cairo code. The third party will then proceed to compile your Sierra program into Cairo assembly in preparation for its execution in the Cairo virtual machine. The output of the Cairo virtual machine is a trace that is sent to another module called the prover, which would be in charge of creating a validity proof attesting to the integrity of the execution. The output of the prover would be the output of the computation and the associated validity proof. Before you can trust the given output, you would check the validity proof with a verifier program that you can run on your device, as it doesn't need much computing power. If the verifier confirms that the validity proof is correct, then you'll know that the output of the computation provided by the third party is also correct. This is of course just an example of how Cairo could be used, but doesn't exactly reflect how Starknet works, so let's dig a bit further. The first step is the same as before. You start by compiling your Cairo program to Sierra on your computer, and then send it to a third party to execute it. Here, Starknet takes the role of the third party, the entity in charge of executing your program and generating a validity proof for you to verify. The system follows the mantra, don't trust, verify. The actual Starknet node that receives the Sierra code of your program is known as the sequencer, a powerful machine that is in charge of executing your code. Just like before, the sequencer needs to compile your Sierra code to Cairo assembly before it can run it on the CairoVM. The trace generated by the CairoVM is then sent to another Starknet node called Sharp, which stands for Shared Prover. As you can imagine, the main module of Sharp is the prover, which is in charge of generating the validity proof out of the execution of your program. The validity proof is then sent to Ethereum for verification in a special smart contract written in Solidity called the verifier. This verifier smart contract is specific to the services supported by Sharp, which includes Starknet, StarkX, and app chains using Starkware's tech stack. If the verifier successfully verifies the provided validity proof, then you'll know that you can trust the result of the computation. Sharp provides both the output and the validity proof of the execution of any Cairo program. Now, is this exactly how Starknet works? No, this is still an oversimplification. For starters, Starknet doesn't just run any Cairo code, it runs smart contracts. Before a smart contract can be executed, the code needs to be declared and an instance of that code needs to be deployed. Only then you can interact with the smart contract. Users interact with smart contracts on Starknet using transactions, which means that there are modules for signing and verifying signatures that were not shown in our oversimplified diagram. As we move along in the course, we will add more details to how Starknet actually works step by step. For now, the diagram shown before is a decent approximation.